Okay, so welcome to everybody. Thanks for being here. You are the brave one, and I also give my greetings to all that follow online. So I'm very glad today to present Mario Cammarota, research manager at Unox, for actually the second seminar of the cycle about the physics of data and digital transformation. And Mario joined Unox in 2013 after the master degree in physics. He was actually my classmate. And he did also a PhD in neurobiology, and then where he developed mathematical models and innovative experimental approaches to study neural networks in physiopatology. Okay, so you see how from neuroscience you can then go and work in this fascinating world of artificial intelligence and cooking. And so in fact at Unox, Mario leads a team whose mission is to design and develop smart cooking appliances for the most demanding professional catering market. This is what he's going to tell about us, and he will also present possible stages and projects that for the students that are interested can then discuss with him. And thanks, Mario, for being here, and I'm very glad to listen to you.
Thank you, Samir. As Samir told you, I also was a student that spent a lot of time in this room, so it's really every time beautiful to come back here. Okay, Samir already introduced me. I just want to spend a couple more words, not really because I think that you can be interested in me, of course, but only because I'm a physicist, so maybe my story can provide you some inputs about your future. Then a couple of words about Unox. Then I want to try to explain you what really a digital oven is and why and how we tried to develop such a digital machine to cook food. And finally, I want to present you some projects that we are working on, and I really love work with physicists. They are much better engineers, as you know, but don't tell to engineers. And so I will try to convince you that we have some interesting projects also for you. I enrolled at the Faculty of Physics at this university in 2003, so many years ago. And I remember that one of the main reasons that pushed me to make that choice was because I read that book the summer before my enrollment in the university. Have you read it? No, I strongly suggest you to read this short joking Mr. Feynman. Do you know who Feynman is? Okay. Feynman was cool, so I thought that was cool to be a physicist. Actually, the reality is rather different from what Feynman describes in the book, but it's really a funny book. So, and my dream at the beginning of my university years was to, have a life like that with very big blackboards full of complicated formulas, trying to penetrate the deepest secret of the universe and of the atoms. I wanted to become a theoretical physicist. You too, Samir. I followed all the math courses the first 3 years. But I changed my mind after a couple of years. I kind of felt in love with another subject, the brain, human brain, so the essence of the human. I made a thesis, as Samir told you, about the interactions of neurons and another population that everybody knows that in the brain there are a lot of neurons, but actually the most abundant cell population are the glial cells, and in particular these astrocytes are really very important because they modulate all what is going on as synaptic activity is modulated by astrocytes. And I made a thesis, and then also I made a PhD studying and studying the interactions between these two cells population in physiology and also in pathology, in particular in the genesis of epileptic discharges. And then finally, starting from the universe, human brain, finally at the end of this descending climax, my job today is try to understand how to perfectly cook chickens. Okay, that's what I do today. But if I'm here, it's because I really think that for a physicist, it can be interesting to understand, to penetrate the secret of the chickens, actually. At Unox, we produce professional ovens. When you think about professional ovens, forget about the oven that you have in your home. A professional oven means that it is a machine that really goes inside a professional kitchen. That means a kitchen of business. Okay, something that must produce food for business. Must cook food for business. An oven in the kitchen of one of our customers is a productive machines, 100%. Okay, like we have the machine that cut the stainless sheets in the kitchen. There is an oven, and that means that the performances of this machine must be rather different from what in your house in terms of cooking uniformity. One of the tests that our customers do, professional oven can like this 5 trays or like this 40 trays. They cook, for example, 40 trays of croissants. They put 40 trays on the floor and they look if all the croissants are identical one each other, okay? Cooking uniformity. Then the speed of cooking is really very important because it means productive capacitance for our customer. The reliability, of course, is one of the most important features. Some of our ovens works 24 hours a day, 7 days a week. And you really don't want that an oven stops to work during a service in a restaurant. It's a tragedy, okay? Basically, our customers, everybody that cook food for business, from the little bar to the restaurant to the free Michelin-star restaurants, up to the supermarkets, hospitals, very big caterings that produce thousands of every day. This is what we do. And in particular, as Samir told you, my team, the research team, is responsible to produce all the technology that we implement inside the ovens. I like that we think about food as soft matter, okay? It's matter that is transformed during the cooking processes. In perspective, an oven is just a chemical and physical reactor. The first step of all our innovation is to understand how physical and chemical reactions transform the food. We always start from that. Also because in my team there are a lot of physicists, so we like this kind of stuff. We try to understand the result that the customer desires, for example, steamed rice, okay? We study how some reactions that happens in starches can modify the structure, the physics of the rice. Then we study how all the physical variables that the oven can manage that are now a lot, not only the temperature, but also the concentration on vapor, water vapor inside the cavity, the concentration of oxygen, the velocity of this atmosphere inside the cavity, in some cases, the intensity of the electromagnetic field inside the cavity. We try to understand how the behavior of these variables can impact on those reactions. And finally, the third step is develop pieces of technology that technology, I mean both hardware, so a new fan, a new engine, a new geometry in the cavity, a new valve, new pump, and I would say most of the cases like that, software, so control algorithms that can really help the oven to manage all this physics. I really very proud to tell you that what I think that distinguish Unox from the other ovens manufacturers, that we really believe in innovation. Of course, I'm to in front of you. Of course, I must say something like that, but it's true. Think about that. In my team, we are more than 25 persons that do only research, okay? Without all the mechanical engineering, the electrical engineering. In a company that counts 600 people in all the world, it's a huge amount of people that do research. And I think that this is one of the reasons that, sorry, one of the most important factors that allowed Unox to get all these small labels there. The Great Place to Work is a society that certifies that the workplace environment. Okay, if you get one of these labels, means that your company is really very good for the employers. Basically, they submit a survey to all the employers. All the employers vote something, and if you have a high score, you can get these labels. In 2021, we got the Best Workplace for Innovation label, Best Workplace for Women label, Best Workplace for Millennials, and also the Best Workplace overall in Italy. We are in the first 10 Best Workplace in Italy. I think that it's something very important in my everyday life, to have a good environment when I go to work. A couple of numbers about Unox. We, in 2021, we have revenues of 180 millions, growing by 10% with respect to the year before, and 25% with respect to 2019, that before COVID. We are more than 600 people everywhere in the world. All the operations and all the innovation department are here in Italy, basically 12 kilometers from here, Cadoneghe. And all over the world, we have only sales subsidiaries. So with salesmen and with technicians that go to repair the ovens when the oven need to be repaired. Basically, as you can see, they are everywhere in the world. Americas, Asia, Africa, Australia, Europe, of course. Just to give you very briefly an idea of what I mean with that we are an innovator, I'd like just to cite some milestones that, in my opinion, are really very important. 1990, all the combi ovens before Unox ovens manage the convection. So inside an oven, one of the most important way to exchange heat and then to trigger all the chemical and physical reactions that transform the food inside the cavity is convection, of course. Fan that move air. Before Unox, all the ovens manage convection using very big fan. The bigger the oven, the bigger the fan. We invented a new system, the name is Air Maxi, that replaced this idea of big fan with many small fans. At that time, we didn't, was just, let me say, an intuition that the owner of Unox had at that time. Now that a lot of tools, for example, to simulate the cavity, to perform CFD simulation, we know for sure that that is the best way to get a very good airflow everywhere, very uniform airflow everywhere inside the cavity. And so we studied this system that is not only performant from a convection point of view, but also from a productive point of view is really smart because everything is modular. I need the 5 trays, just one fan with one engine, and all you need to mount this fan and this engine on the oven. If you have a bigger oven, for example, a 20 oven, you need just 6 of these modules, but the system is modular. This is super good from a productive point of view. At the end of 90s, we also, I think that here in the northern Italy, Unox was one of the first companies really try to implement inside its productive system the Toyota philosophy. You are a physicist, that you don't know anything about that, and I don't want to bore you about this, but this slide is good also for the engineers, so sorry for that. Anyway, Toyota Industrial, the lean system, means to try to focus on the, in Japanese, the word is okay? In Italiano è sprechi, okay? And try to study and to design the productive process in order to get rid of this. Also from the sales point of view, Unox was innovative. We firstly choose as salesmen chefs, okay? Chef that doesn't to work more in a restaurant. We hire this chef, we teach him how to sell things, and he is the salesman that go to our final customers, showing them the ovens. We call the equal cooking experience. It means that Unox, the name of our salesman is Active Marketing Chef, so the AMC, go to the restaurant with the oven, put the oven inside the kitchen of the customer, and then make some test and cook something in the kitchen of the customer. Not just a demonstration, general demonstration, is customized for each customer. 2015, this is one of the first job of my team. We developed an algorithm that is called adaptive cooking that allow the oven to automatically manage different amount of load inside. Think about a very big oven. If you have to cook just one tray of bread, you will use a certain cooking program, time, temperature, humidity, and so on, all the cooking parameters. When you put a full load, 40 trays, of course, the first program is not good for the 40 trays, okay? You need more time, more temperature. You need more because the load is huger. Adaptive cooking manage this automatically, so the oven can sense how much load there is inside the cavity, and then modulate all the physical variables, temperature, humidity, automatically. 2018, another very cool project. We invented the first hot fridge. We developed, and also we have some patents about that. A totally new preservation process. Now you use of course, the fridge because you keep the food at the temperature below the bacteria proliferation temperature. You freeze the bacteria. But for a restaurant is really very complicated because you have to cook the food, to cool down the food, put it in the fridge or in the refrigerator, and then before to serve it, you need to regenerate it. With this process, you don't need all these passages. You just cook the food, put it in the hot fridge, the name is Avereo, and you can serve it. This technology is based on two very important things that we are able to manage very well. The temperature, of course, you need really to be very precise, because if your temperature oscillates too much, the food is safe from a microbiological point of view, but it's not good. Second, the concentration of oxygen, because you need to get rid of all the oxidations reactions that can impact on food quality. And finally, this is what we have launched a couple of months ago, the first ever self-cleaning combi speed oven. This oven that can cook using convection, can cook using condensation of steam inside the food, can generate microwaves, then accelerate the cooking process using microwaves, can also is automatic, is self-washing, all inside just one. And also this oven, I will show you something, is, in my opinion, a very good example of a digital oven, and what at least we mean digital ovens. I go fast here. One of the most important point of Unox philosophy is to verticalize all the processes. When we start to do something new, for example, some years ago, we decided to produce internally the detergent, the chemical that we use to wash the oven. Usually we find outside Unox some competencies. We take these competencies at home, and then we spin off a new company that manage these competencies. And so basically more than 90% of what we have inside the oven's components is by our companies in the group. So trays, all the stainless steel that we have in the oven, also the electronics. Now also the assembly lines, the detergent, all the plastic components are all produced by companies of Unox Group. We are also try to be very sustainable. This is very important for us. I don't go really inside the details of this slide, just to tell you that one of the most important impact on sustainability that a company like Unox has in the world is the product. We can be super sustainable in our factories, but if our products are not sustainable, this is a very big problem for the environment, because an oven is super energy, use a lot of energy. So that logo, Energy Star, means that all our machines have that logo that certifies that our products, our oven are super good energy efficiency. Okay, so let me talk a little bit about digital oven. I show this slide because 2014, the first time that we mentioned, because now everybody talk about digital transformation, digital everything. 2014 was different from today, trust me. Basically, Unox was a mechanical company, and our products, mechanical products, just stainless steel boxes with a kneading element inside. A story that inspired us a lot was the story of Kodak. Do you know what Kodak was? Early 90s, top player in the market of photographic films. One day, Kodak engineers went to his boss' office with something. This is a prototype of something that translates images into matrices of numbers. I want to call it a digital camera. The CEO of Kodak was not happy with the quality of the images produced by that object, and the project was rejected. As I think you know, some years later, Kodak was killed by digital cameras. This is one of the most important human bias, in my opinion. We are able to think in a linear way. So when we think about the technology, we project in time the evolution of the performances of that technology in a linear way. The problem is that digital technology are not evolving in a linear way. they are evolving exponentially. It means that at the beginning, our perception is much more, it's much higher than the real performance of the technology. But at a certain point, when the exponential growth start to really run, and so at the beginning we are disappointed about the result, the performance of the technology. Later we're amazed. This story teaches us that we really needed at that time to a big change in our design process. We started to invest in hiring people that was expert of digital things. At the beginning, I think that the technical office of Unox was only mechanical engineers. Now we have a lot of different engineers, physics. So it was really a very important step. And also, why the digital technologies evolve in an exponential way? That's explained by the Moore's law. Do you know the Moore's law? I think that states that every 18 months the power calculation of the computers, the chips, just double. That's why all the technologies that are based on computers are evolving in such a fast way. I can really feel this because now, because I asked to the people in my team, how much time do we need to have the results of this simulation? A couple of years ago, the answer was we need a week. Now we need a couple of hours. And so we decided that at that time, our top range product, Mind Maps was the name, all the oven, Mind Maps oven, must have by default the internet connection. At that time, we really didn't know how to use this data, an internet connection, and all of this oven must send to the cloud, some data every 30 seconds, some data. At that time, trust me, we didn't know really how to use that data. But if you wanna, we have a model to describe digital products, a 3-level model. The first is the level of data. A digital product must be able to produce data. For data, I mean, of course, numbers. Digital means from Latin, count with the finger. Count with the finger means numbers. And so we decided that the oven must have something that can produce data and something that can send data somewhere. When I say something to produce data, of course, I am speaking about sensors. One of the side effects of the Moore law is that the performance is increasing exponentially and the prices of the technology is decreasing exponentially. Because now everywhere these pieces of technology, sensors is just an example. On your smartphone, you have a lot of sensors, of course. On your car, if you have a lot of sensors. That's why we also at that time we decided to put sensors inside the oven. What now is true, at that time was not. So just to give you an idea, in 2000, all the ovens. This slide is in Italian, but I'm going to explain it. The number of sensors. A sensor is something that translates some characteristics of the environment, of the reality, into numbers. The job of a sensor. Number of sensors, 2000, 0. Also, the temperature of an oven was regulated by a thermomechanical object. Thermostat is something that when a temperature reaches a certain value, just close a contact, and this contact close can allow the system to supply an heating element, a resistance somewhere. 2010, I think that in the market, maybe a couple of temperature probes inside, and for temperature probe, I mean really an object that can measure the temperature and log it and create a list of numbers, okay? 2015, when we launched our MindMaps oven, we put all those sensors inside. So more or less sensor, temperature sensor for the cavity, but also for the food, because you can, insert the core probe inside the food to measure the temperature of the food. Some sensor to measure the voltage and the current of the boards, the electronic boards inside the oven. A sort of soft humidity sensor. It really does not measure directly humidity, but okay. Now, the oven that we are launching contains all those sensors, and on the top of that, a camera, a microphone, for example. Ok, il leader is not really a leader. Ho scritto solo perché faceva un po' più figo. A time of flight sensor, something that can measure proximity, something to assess the quality of the water that you are injecting inside the oven, much more. And of course, in the future, I don't know, we are already studying something about nanotechnologies in sensor developments. Of course, we are interested in graphene. Everybody's interested in graphene. So one of the biggest challenges of the future is to design the sensors of the future. Just one point about that. I think that one of the biggest side to explore is to find sensor for the food. Now all the ovens just measure something inside the cavity, the temperature, the humidity, times the density of the electromagnetic field, the speed of air, but it's really very difficult to measure some characteristic of the food. So this is, in my opinion, one of the biggest challenges. One of the projects that I'm here to propose you is about this. Okay, so I told you before a three-level model. The first is the data. The second is the elaboration. Once you have a data, you must be able to transform this data into valuable information. Our customer don't give a shit about all those numbers. We need to transform this number into value. I want to go fast about that. I'll just give you a couple of examples. We developed, we call even cooking, that is a platform in which the customer can really go inside the data that his oven is acquiring. Think about a supermarket, chain of supermarkets that own 20 ovens. This is really very useful to do statistics and to understand how oven are used, if the oven are well used. And of course, the other, that is, I think, the most important application of this elaboration process for us is to develop smart control algorithms. We are using that data real time. The oven is using that data real time to increase the features, the performance of the oven. I really don't have time to go into the details of this slide. I just want to give you, I told you before about adaptive cooking, pressure steam, and other algorithms. I told you that we always start from the food. 2017, we had a problem in the Chinese market. You know that problem always implies an opportunity. In China, it's really very common to eat and to cook the dumplings. Today, the dumplings in China are cooked in traditional steamers that are a very big pot full of boiling water. Super good because the dumplings, the cooking result is perfect, but not really very efficient, not really very automatic, not really very smart. So the challenge was to make the oven able to perfectly cook the dumplings. So we started this project trying to understand the chemical and the physical of the dumplings, and at the end we developed a new algorithm that using data numbers, using the precise measurement, humidity, and an estimation of the temperature of the heating element, was able to manage the injecting, the operation injecting water to produce steam, and the management of the power to get the perfect result, the perfect cooking result. So you have data, you elaborate data, you can use it to increase the performance of the oven, and you can use it to give important information to the customer. The third level, when you have data and you know how to transform them into information, using your know-how, the know-how of the company, you can be able also to create something that is able to predict something. I don't want to bore you. You know much better than me what a neural network is. In the product that we have launched, we are using neural network to do settings, to do voice recognition. We are going to use them to perform machine vision, as Filippo knows. And also we tried, and some of you were involved in this project to do the so famous predictive maintenance. That means that every 30 seconds, all the oven in the world send data inside our house. And so we tried to train something, a model, in order to know in advance when a specific was going to have an issue, to have a problem. Okay, basically we failed. Okay, I think that the idea that I have about that failure is that when we built the database in 2014, we really didn't build it thinking about such an analysis. So I think that the data set was too dirty. Maybe the best, the more noise we have. So basically the result of the project, honestly, I can tell you that was like flip coin to try to estimate if an oven have a problem or not. In the oven that we are launching, of course, we have time now to design properly the database, the data set. Then this is another project, okay? Try to build a predictive maintenance system for our ovens. About this, of course, we are using this data. They are super precious for us, but the approach is different. It's more physics-driven than data-driven. If we have a problem in the field, we can interrogate the database. We can try really to investigate, like Sherlock Holmes, looking at the data, trying to discover patterns. It's not automatic, but it's of course something that is very useful for us. Here we have the number of connected ovens. You see they are increasing a lot. And just to give you an idea about how to measure the digital content of a machine, here we have the incidence of the cost of the electronics. For electronics, I mean sensors and electronic boards. So sensor and calculation. As you can see here, right now we have that. Actually, this is underestimated. More than 50% of the cost of the machine is intelligence. We come at what we have today. This is the slide of the marketing. Just to give you an idea, this is the last product that we launched. The name is PDX. It is an oven that, as I told you before, can use convection to cook food, use steam, produce and manage properly steam. It uses also the electromagnetic field, and the oven can do all this stuff properly. And we also developed really, starting from zero, an open system. What you are seeing there is something that we have developed starting from zero. we have some amazing feature that, of course, we don't do fundamental research. Of course, it's amazing in our market. An oven, we can do a sort of Zoom call using the oven. We can speak with the oven and give orders to the oven. The oven will be able to automatically recognize what we are putting inside it. And so to do this, we need a lot of smart people. Now I come, how much do we have? 5 minuti. Which are the trends that we are following in our research activity? Of course, sustainability. This is one of the biggest challenge also, because now in some markets is a conditio sine qua non to sell the oven, that the machine is super efficient. Of course, AI, I provide you a couple of examples, machine vision, voice recognition. Of course, now the robotics is something that exponentially is growing and is coming everywhere, also in the kitchen. So we have to really remember the story of Kodak, and we have to be prepared to have something that can automatically also physically manipulate food. And so these are the trends on which we are building some projects. I anticipate do something about that. The oven is already digital, but we wanted to digitalize also the food. That means transform the food into numbers, that means to study and design innovative sensors to do this job. We are working with physics professor at the University of Parma that is helping us to do this. We have started a project of robotic cooking automation. The aim here is just to build a machine that not super general purpose, because we don't know if that will be the future of robotics in the kitchens, but maybe that can do very well 1-2 operations. But we are starting from zero. We are trying to develop this deep cooking project, and I asked Filippo to tell you something about that.
Yes, so deep cooking process has the main goal to produce an oven that is intelligent and is able to adapt his cooking algorithm to the needs of a customer while maintaining a consistency in cooking. A first step in this direction was done by me and my 2 physical data colleagues by creating a physical simulator that is able to approximate thermodynamical and chemical processes that happen inside the oven. This way, we are able to predict and to replicate the main observable that we are interested in during the process of cooking. Thanks to this simulator, we will then be able to produce large simulation of cooking processes, and also thanks to experimental dataset, we will then be able to exploit advanced machine learning and learning techniques in order to predict what a cooking algorithm can as a final result. So I can leave Mario the voice for further comments.
Yeah, so the idea is, as Filippo explained you, first we need something that can produce data, and then we want to use those data to train an algorithm. The final aim is really that, and we do this operation now by the phone. If a customer has a cooking problem, my chicken is not well roasted on the surface. They called us, we try to understand this problem, and we try to provide him some advice to try to change the temperature, try to change Also because to have a automatic program is absolutely impossible. A chicken, I started with the chicken. An Italian chicken is rather different from a Chinese chicken. I was in Chile roasting chickens with our customers. The water content is totally different. So if you use the Italian program to cook a chicken from Chile, the result is completely different. So deep cooking is, the aim is, okay, the customer has a problem. The customer tells directly to the oven what the problem is, and is able to modify the cooking parameters to go into the desired result. Now we have 3 students of physics of data that are working on that. This is more standard, but of course, super important for us. We have already developed a machine vision project. We are using convolutional neural network. We are doing transfer learning. Just a comment about that. You know better than me what a neural network is. Of course, knowing the mathematical details are super interesting and can provide you a deeper understanding, but in the reality, you should use this. So the challenges are how to, for example, build a super scalable system using this stuff. Also, today is a commodity using neural networks. With Google, with the AWS services, really you just press a button and the network is there and you can use it. Well, I think that was with you that we have some field tests here in some restaurants. The process is that, okay, we come with the oven in the kitchen, in the supermarket. We do the training, okay, putting manually, one of our servicemen put manually the trays of your food, because we have to do transfer the learning in the last layers of the network to really, because machine vision, our sector, can work only if the accuracy is 99.9%, because there are some mistakes, because the customer, especially in the supermarkets, the problem is that they insert a load and they choose the wrong program. And this is not good, because the result will not be good if you choose the wrong program. But the percentage of error is so high, so we really need the super high accuracy. So we need to do the training there. We performed the training. The accuracy on the training site was amazing, 99.9%. When we started the test, actually on the real test set, when the customer was using the oven, the accuracy drops down dramatically, 80%, something like that. At the end of the day, we discovered that this is one of the problems, that we performed the training when the oven was cold. When the customer used the oven is hot. By eyes, was impossible to see a difference between the images, but the camera will sense these differences. So I think that you, Filippo, Lorenzo, and Tommaso studied to manage this, to correct for temperature, correct? Am I correct?
I think that the problem was temperature and some not regulated, and then
of course. So this is one of the real problem. Now we want to also study an object detection system. We want to use a network that analyzes all the image in the field, but we want something that is able to identify objects inside the field. Okay, I go faster. Just last 2 slides. This is not really focused on data, but for physicists, it's really very important. One of the biggest challenge of the microwaves is that they are not uniform. The wavelength is 12 centimeters. There's no way to have uniformity inside the cavity. Actually, today, do exist some new generate electromagnetic field. Today the oven use magnetrons that are stupid object. Do exist a new technology that is solid state technology, but is super expensive. So nobody is using it. I think that in the market is just one oven, is a domestic oven from Miele that costs 9,000 euros and also is super shitty oven. So one of the biggest challenge in this, because speed is another very important word in this era, to find a way to be super uniform without using solid state. So how can we manage the coupling of the electromagnetic field from the magnetrons in order to increase the uniformity inside the cavity? Sustainability, we are working on the hydrogen oven, new materials, of course, sustainability, insulation, but also cleanability and the reliability of the oven. Finally, this is my last slide. We have several ways to collaborate with the students. The most standard is the internships, the thesis, so on. We are super interested in you about that. But we also have, and Filippo, Lorenzo, and Tomás are using this formula. We call it Unijob. It means that you come at Unox and you work as just 1 day a week. We pay you as an employer. It's a little bit different because usually when you are an internship student in our lab, you have a project to follow. If you are a Unijob, maybe we ask you to work on different projects. So the scope is a little bit different. But I think that is my experience was a super good way to smart people, brilliant people among students. Okay, thank you. If you have any question, I'm here to answer you.
Thank you. So, okay, we are ready. You. So I guess that we can now stop and ask a question about also possible internship and thesis. So the page of the project, I will upload this presentation also in the Physics of Data internship web page. So those who are interested can look, and that's it. So I thank you again, Mario. Now lo spazio a domande più informalmente, tanto è inutile che continuiamo a registrare. And I will remember that in 2 weeks, I think Tuesday, 14 March, there will be the next seminar about physics of data and digital transformation. Dr. Bardazzi, that is a founder of an entrepreneur that about a digitalization process. So I will send to you all the flyers and info. Okay, so thank you very much again, Mario.
Thank you.
E adesso, insomma, se avete un applauso.